Okay. This first section is review for you. How to plot points on the grid and how to read points off the grid. Okay? We use grids for a lot of things in real life. Anytime you want to determine locations, you use a grid. Anytime you want to visually show patterns or visually show equations, you use a grid. Okay? Much of what we model in real life can be broken down mathematically and shown on a grid. So we're going to be using this a lot in the next 4 years. So here's what the grid looks like. We've got a whole bunch of squares, okay? And we've got two main lines. We've got a horizontal line called the x-axis, and we call the vertical line called the y-axis. And the point where they meet is called the origin. And what we want to do is we want to attach numbers to each location on the grid. The origin is our reference point. That's where we count from. So the origin has the coordinate or the numbers 0, 0. Okay, that's what we use when we want to plot points. That's what we use when we want to read points. So we can go in 4 different directions from the origin. We can go to the right, we can go to the left, we can go up, we can go down, okay? And then we count how much we go in each direction. Depending on the direction, it could be positive or negative, okay? The first number always tells me how much do I move right or left from the origin. If this is a positive number here, I'm going to go this way. If this is a negative number, I'm going to go this way. The second number tells me how much I move vertically. If it's positive, I'm going to move up. If it's negative, I'm going to move down. Okay? So for example, if I wanted to plot the coordinate 4, 3, I would start at the origin, and since the first number is 4, I'm going to move 4 to the right, and then I'm going to move 3 up. And that's the point 4, 3. Yes, stunning. What if I wanted -5, 1? Well, I start here and I go left 5, but then I go up 1. And that's the point, -5, 1. Okay? I will practice with that a little bit more on the next page. So, when we draw these x and y axes, we split the grid up into 4 what we call quadrants. And we always count the quadrants starting in the upper right and moving counterclockwise. So in quadrant 1, this section. Quadrant 2, quadrant 3, quadrant 4. Yeah.
But why did you like running your
Because that's sort of the way it was used when it first started, when it was sort of first developed. That's why. Okay. You'll notice, and I write this on the second page, that every point in quadrant 1, the 2 numbers are always positive. Every point in quadrant 2, the first one's negative, the second one's positive. Every point in quadrant 3, they're both negative. And every point in quadrant 4, the first one's positive, the second one's negative. So let's just do a little practice. And rather than write the coordinates, let's just put letters. Where they should be. So I want you to plot all 6 of these. Remember, we start at the origin where the axes meet as our reference. First one tells me to go 2 to the right and 3 up. So that would be the coordinate A. Another phrase we use for coordinate is ordered pair. Anybody want to plot B? What do you see?
Can I do D?
Yes.
Yeah, wait, is it?
-3, 1, yeah. Good.
What am I doing? C? D.
-2, -4. So let's see. Good. Anybody want to eat? Sorry. All right, yeah. How about that?
Pretend that it was really bad.
How about
You know,
that?
can I do it?
David can do that.
Wait, is this E? Wait, I haven't.
That is he. Yes, ma'am, sorry.
Wait.
What sort of language is this here?
It's actually hard to write on it. What? Oh, yeah, that's my D. It kind of, what is this? It's hard to write on this board.
Not really.
Well, like if you write small letters. Yeah, that's like it's too small. Yes. After a line, it's like a big line.
It makes it, for some reason, there's a glitch. Yeah, the file is corrupted, so there's a glitch. Okay, so you get an idea of how to plot points. The other way, having given the points, you have to write the coordinates. So for example, what would the coordinate or ordered pair of A be? 4, 2. So we just write 4, 2. And then you do the same thing with the remaining ones. Okay. That, I'm hoping, should be reviewed.
Like the first part more than this part, but we get like that from the Susan. Like I feel like I have that from like Jack and them. Yeah.
Yeah, I'm thinking you probably learned it before grade 7.
Pictures though, like.
Yes. It's,
Yeah, we would like, yeah. That was good.
I hate to tell you, but we're kind of past that. How about this one?
Whoa, I'm not. Which one?
-2, 5. Well, because you start here and you say, okay, how much do I have to move horizontally? Well, I have to move to the left 2 to get underneath it. And then I have to move up 5 to finally hit it. What's that?
Did you never go?
I don't know what you said. Oh. C, -3, -3. D,
4, -3. Wait,
yes.
wait, and then 0 equal? And then, okay, guys.
What's that?
How is the -4 first before the -3?
First of all, it's +4.
Oh, that makes more sense.
Yeah. And yes, E is 0, -1,
5.
and then 5, 0. Okay? So we're going to need that because we're not going to be just plotting points. We're going to start to plot points and then draw lines with them. And then as we move on in the grades, we're going to start adding curves. And then before you know it, you're going to be in calculus.
Last year we did the data table.
Yes. Yeah, we're gonna review that.
Yes, and then we have to like graph it on the chart and like make it live.
That's right. Okay. So let's actually start looking at how do we take equations and show them on a coordinate grid. All right, so here we have a pattern. We have figure numbers. And we have the number of squares inside the figures. Okay, and the squares, they're all 1 unit long. So what we're going to do is we're going to find the relationship between the figure number or the because they form rectangles. So the rectangle number but we don't want to use all those words, so that's why we use just a single variable, lowercase letter n. And then for each figure number, we're going to figure out what their perimeter is. So rectangle number 1. What is the perimeter if each of these is 1?
Oh, 4. 1, 2, 3, 4.
6. 2, 3, 4, 5, 6. Yeah, we don't count in. Figure 2. 8. You should probably be able to see a pattern developing already. 10 and 12. Good. Now, notice we can actually take all these numbers and make ordered pairs.
So 1 and 6.
Right. And if we can make ordered pairs out of them, we can show it visually.
But how would you do negatives like that?
Well, okay. Is it possible to have a negative figure number? No. Is it possible to have a negative perimeter?
This.
Really?
This, no.
No, I'm talking about in life. No, you can't have a negative, right? It's got to be positive. So really what we're doing, show it on the graph, is we only have to show the first quadrant. We don't have to show all 4 quadrants. I'm just going to draw the first one. Right? Like normally we would draw like that, but we don't need to because everything's positive. Well, now we've got a label. So I've got n, the rectangle number. It's going to be, because that's the first number, that's how we move horizontally. And capital T is the perimeter. Now I have to choose the scale. Okay. How much do you want to go up by each grid line?
2.
2? Won't that make it a little small?
3, 4.
3, 4? It'll make it smaller. Go up by zeros.
Go on by 1. 1,
10.
So
No, the higher it is, the smaller your figure's going to be.
I'm
Go up by ones. Like even that's a little small. Because remember, we only went to how many? 4.
we can do 0.5.
Yes, I mean, another one would have been good is go up by a half every time. Because you don't want your figure to be too squished. Now look at the numbers for the perimeter. 6, 8, 10, 12. How much do you want to go up by? 2, so that's probably a good idea. 4, 6, 8, 10, 12, and then I'll just stop this. Okay. And now we plot our points. So for figure number 1, we had a perimeter of 6, the 0.16. For figure number 2, we had 8. For figure number 3, we had 10, and for figure number 4, we had 12. You can see, not only did we see a pattern in the table, but you can see a pattern on the graph too. Yes, it's forming a line. Okay. Now the question is, and this is something that you're going to have to figure out, do I draw a line through them? Okay, first of all, don't copy this down. Would I draw it like that? Why not?
They're all
Is it okay to have an arrow this way? Yeah, because it keeps going up, but it has to start,
0. It has to start over
has to start at 0? Is there a figure 0?
1.
It has to start at 1. You're right. So we can't have this. We can't have this. Okay. It's got to start at 1. Am I right now? So are you telling me that figure number 1.5 would have a perimeter of 7? Is there a figure number 1.5? No, there's no. It's counting numbers, 1, 2, 3, 4. You don't start at 0, you start at 1 and you go up by ones. So we can't even have a line through it. So what we have to do is something like this. So let me just plot these again, 6, like so, like so, like so. We do not connect the points because you cannot have part of a figure number. But we want to show that it goes on. The pattern continues. So I draw a little arrowhead at the end like that.
From the point, or just
Don't just pass the point in line with the 4 points. And then just an arrowhead. Because that just says, yeah, we can keep going up. You can go to figure number 5, number 6, number 7. Okay? But we can't connect the points. That's going to be something that you guys are going to have to answer. When you plot a graph, okay, can you connect the points? All right, the last thing that we want to do is we want to write an equation for this. So remember, the second variable is always the beginning of the equation, right? So P equals, what's the equation? What do I do to N? This is what we did at the beginning of class. What do I do to N? How much am I going up by every time?
2.
So that implies times 2, right? So N times 2 But then how many short am I?
4.
N times 2 is 4 plus 4. And minus 4
Plus 4. Wait, oh yeah.
plus 4. 3 times 2 is 6 plus 4 is 10. 4 times 2 is 8 plus 4 is 12. So it's going to be 2n plus 2.
Plus 4.
Plus 4, sorry. Thank you. Okay. So like I said, or actually, sorry, we won't, I'll go to the connecting points in a second. So we've got some names to use. So we always calculate the perimeter from the figure number. Okay, so the perimeter depends on what the figure number is. Therefore, the variable we give to P in this example is the dependent variable, because it depends on what n is. And what we plug in is called the independent variable. You guys get this in science? Oh, okay. When you graph these things, the independent variable will always be the x-axis, the horizontal. And the dependent variable will always be the y-axis, or the vertical. Okay? You can even tell which is independent and which is dependent from a table. If you go to the previous page, the first column is always the independent. The second column is always the dependent. On a graph, the independent is always this. The dependent is always this. Okay? Okay. So what we've been doing in the previous lesson and this one is we've been showing a relationship between two variables, figuring out an equation, now showing it visually. Okay. Well, what do we call that when we're talking about the relation between two variables? Why don't we just call it a relation? And when that relation, when we graph it, if it forms a straight line, so it's either a line or it's either a series of points that forms a straight line, we call it a linear relation. And in a linear relation, for every constant change in the independent variable, there is a constant change in the dependent variable. Just a little bit of okay. So in this perimeter example, figure number. So in the example we did, every time the figure number, which we called n, increased by 1, the perimeter, which we call capital P, increased by 2. That's what linear means. So how do you tell if something's linear? Well, if you're given a graph, if it's a line, that's easy. It's linear. Okay. If you're given a series of points and you can draw a straight line through it, that's linear too. If you're given a table, as long as there's a constant change in the first column and a constant change in the second column, it's linear. And that change could be up or down. Okay. So let's just look at this graph that I did. Here we have something happening over hours. And depending on, or your distance, I guess, traveled, walked, driven, cycled, I'm not sure. Depends on how many hours you traveled for. So for example, you should be able to read a graph. How far did this person go in 2 hours? In 2 hours?
I mean, in 4 hours, go 40.
40. How long did it take the person to go 100 kilometers?
5 hours.
5 hours, right? Take 100, go to the line, go down, it's halfway between 4 and 6. Okay? Is this a linear relation? Think of the word linear, it has the word line in it. Yeah, it's a line. So yes, it's linear. Okay? If it went like this, that's not linear. Okay? Does it make sense to connect the points in this one? Can you go a fraction of an hour? Can you travel for a fraction of an hour? Sure. Okay, so that's why in this one we connect the points. It all depends on what the variables are. Like in the first one, the figure number, you couldn't have a fraction of a figure number. Okay, but in this one, you can have a fraction of an hour. You can have a fraction of a kilometer. So that's why we connect them. Let's look at one more example. And then we'll pick this up next time. Oh, this is I got to change this example. This is ancient. DVDs. Anybody even own a DVD player anymore? Yeah. Okay. All right. So this table of values shows the cost of renting DVDs at an online store. We're asked to graph the data and figure out whether we join the points or not. And then we're asked to state whether it's linear or not. So we're given a table. Well, actually, we could answer B just by looking at the table. Here's how you would answer B looking at the table. Am I going up or down by a constant amount here? In this column? Yeah, I'm going up by once. Am I going up or down by a constant amount here? Yeah, 3.5 every time. That's linear. Because it's constant change here, constant change here. So I know it's, so my graph should form a line. Okay, so now we got to figure out the graph. So everything's going to be positive. So I only have to do quadrant 1. These are going to be my DVDs. That's going to be my cost. You need to put labels on. Now, how much do you want to go up by on the horizontal axis? Look at the numbers in the first column. What do we got? 1, 2, 3, 4?
Y1.
Go up by ones or even up by halves. Maybe just to make it a little, because like if we did 1, 2, 3, 4, our graph is going to be switched in things.
Whatever.
No, that's a completely different thing. I can go up by whatever I want to. So let's do this. Just to spread it out a bit. If you went up each one by 1, yes, you would get a squish graph, but it would still be okay. What about the cost? Look at the numbers here. So we've got 350 and we go all the way up to 17.5. Well, we can't go up by, I don't think we can go up by ones because there's not enough to get to 17.5.
Yeah.
Go up by 2s? Okay. And instead of, and you know what, we're going to save ourselves a little bit of time. Instead of writing every one, I'm going to write every second one. So that's going to be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Now we got to plot our points. Well, so 1 is 3.5, right? Well, here's 2. Here's 3, right? Halfway between. So wouldn't 3.5 be somewhere about here?
Yeah.
We're not going to be perfect, but it'll be close to 4, but a little bit under. $2 is $7. Well, here's $6. Here's $7. So it'll be right here. Three, 10.5. Well, here's 10. Here's 11. So 10.5 would be halfway between these two notches. So somewhere about here. And you should see that your dots should be forming a line. Four is 14. Well, 14 is right there. And 5 is 1750. Well, here's 18. Here's 17. So 1750 would be between these two notches. So somewhere about here. And if you do it accurately enough, you should see that they form a line. The question now is, do I connect the points?
Yes, because it's linear.
Just because it's linear doesn't mean you connect the points. You can have a series of points that are linear. Look. What is the horizontal? What is the independent variable? DVDs. Can you rent a fraction of a DVD?
No.
No. Okay, which means no connect. Do not connect. Do not connect. And the reason why is you can't rent part of a DVD. You rent one or you rent 2, or you rent 3, etc. You don't rent 2.5. How would you then watch half a DVD? Snap it in half? How's that going to work when you try to plug it in? Who does DVDs anyway? This is crazy. Okay.